Okay, this is Contemporary Math 7B, and we'll start off with combining probabilities. So the first thing we talk about are independent events. And independent events are where one event does not affect the probability of another event occurring. For instance, if you roll a die twice, the outcome of the first roll does not affect the outcome of the second. And then that leads us to what we call AND probabilities. So the probability of A and B would be the probability of A multiplied by the probability of B. So for an example, let's say we're rolling a die, and the probability of getting a 1 and then a 2 would be the probability of rolling a 1 times the probability of rolling a 2, which is 1 out of 36. And if you added a third thing in there, that shouldn't say and there, it should just be multiply. So let's say we wanted the probability of rolling a 1 and a 2 and a 3. We would just do 1/6 times 1/6 times 1/6. So then we have dependent events. And in this case, the first event does affect the probability of the second event. So let's say we have a box of chocolate or a box of candies. There's 5 chocolates and 5 caramel candies. The probability of choosing a chocolate on your first pick at random is 5 out of 10 or 1/2. You eat this chocolate, what's the probability that you pick a chocolate on your second pick? Well, since you've already eaten one of the chocolates, there are now 4 chocolates and there's only 9 candies total. So that would be 4 out of 9. So the probability of getting 2 chocolates, 5 out of 10 times 4 out of 9, because remember you ate one, so there's only 9 left and there's only 4 chocolates left. So in this case, that probability would be 2/9. So what would happen if instead of eating the first chocolate, you put it back? Well, then the probabilities of those events are going to be exactly the same. Half of the candies are chocolates. You put the chocolate back after picking it. We still have half the candies are chocolates. So for independent probabilities, the probability of A and B happening is the probability of A times the probability of B, given that A has already happened. Here's another example. So you have a 3-person jury must be selected at random from a pool of 6 men and 6 women. What's the probability of choosing 3 men? Okay, so the probability of choosing 3 men is the probability of choosing a man on your first draw times the probability of choosing a man on the second draw times the probability of choosing a man on the third. On the first draw, 6 of the 12 are men. Okay, so a man's picked. Now there's only 5 men left out of 11 total. And then for the third one, there's only 4 men left out of 10 total. So you would just multiply all those together. And remember cross-canceling when you're dealing with fractions. You can do this. 4 goes into 12 3 times. 3 goes into 6 twice. 5 goes into 10 twice. And this would be 2 over 22. No, 44. Sorry. Or 6 out of 66, which is roughly 0.091. And then we have what we call either or probabilities. So a coin can either land on heads or tails, but it can't do both at the same time. Events that cannot occur together are non-overlapping events. They're also considered mutually exclusive. when one thing or another can happen, but the two things can happen at the same time. So when we're dealing with OR probabilities, the probability of A or B, instead of multiplying those two probabilities, we're going to add them. So, for example, a die, let's say we're tossing a die again. What's the probability that you're going to get a 2 or a 3? So the probability of getting a 2 is 1/6. The probability of getting a 3 is 1/6. When we add those two together, we get 2 out of 6 or 1 out of 3. Overlapping events are when one thing can be one event and another event. For instance, this will make it clear. So let's say we have a deck of 52 cards, and I want to know the probability of picking a card that's a queen and a club. So the probability of getting a queen, there's 4 of them out of 52. The probability of getting a club, there's 13 clubs out of 52 cards. And we just add those together. That would be 17 out of 52, which is about 0.337. Remember that this is not the same as the probability of a queen or a club. The probability of a queen or a club would be the probability of a queen plus the probability of a club, but then you would have to subtract the probability of getting the queen of clubs, because you can't count this one twice. So the probability of a queen is 4 out of 52. The probability of a club is 13 out of 52. And the probability of the queen of clubs, there's only one of those. So we have to subtract it from those. So that'd be 16 out of 52, which is about 0.308. So the probability of getting an A or B is the probability of A plus the probability of B minus the probability of A and B. And then finally, we have the at least once rule. So suppose you toss a coin 4 times. What's the probability of getting at least one head? Well, we could do a tree diagram on this. We don't really need to, though, because the at least once rule makes it easy for us. I know that there are 16 outcomes, because when you toss a coin, there's 2 possible outcomes, right? And we're going to toss it 4 times. 2 to the 4th is 16. So there's 16 possible outcomes. The probability of at least one head in 4 tosses would be the probability of 1 head, the probability of 2 heads, the probability of 3 heads, plus the probability of 4 heads. Well, that gets a little messy, and we know that the probability of at least one head plus the probability of getting no heads has to equal 1. So the probability of at least one head plus the probability of no heads is 1. And if I solve for this one, I could just subtract this from 1. So then I have the probability of at least one head is equal to 1 minus the probability of no heads. And if you were to look at all the possible outcomes, in other words, the sample space, you would see that only one time are you going to get no heads. So the probability of at least one head would be 1 minus 1 out of 16, which would be 15/16, which is about 93.75%. So the probability of at least one event in N trials, remember N always stands for the number of times you did the trial, would be 1 minus the probability of no A in those N trials, which is this is just a different way to say it. 1 minus the probability of not A raised to the n power. So let's look at the probability of at least one head in 3 tosses, which would be 1 minus the probability of no heads to the 3rd power. The probability of no heads is 1 out of 2, because there's only 2 possible outcomes. 1 over 2 to the 3rd power is 1/8. So the probability of at least one head in 3 tosses would be 1 minus 1/8, which is 8/8 minus 1/8. It's 7/8, which is 87.5%. The assignment for 7B is the quick quiz on page 450.